Okay, let's do some revision on normalisation, a part of databases most people struggle with. Normalisation is the process of making an efficient relational database. Normalisation takes part in three stages: first normal form, second normal form, and third normal form. I'll explain what those are and what kind of questions you're likely to get asked about them. Well, first of all, let's have a look at what an unnormalised database is. So an unnormalised database is zero normal form. This means no normalisation has taken place at all, and the database has no attempt at being relational. All the data that needs to be stored is one way or another shoved into one table. This is utterly unnormalised. So if this is a library loaning system, then we would need to know the date of the loan, the payment type, the customer ID, the first name, surname, address, the title, author, and ID of the three different books that were taken out. So we've just made a field for each of those things. There's a whole bunch of problems with a table like this. If, for example, you wanted to find out if a particular book was taken out, which field would you search? Some books are stored in this one, some are stored in this, some are stored in this. If you search this for a title, you'd miss the books that are in here and here, which is a pain. What if they only want to take two books out? What do we do with this third one? Do we leave it blank? Do we leave the second one blank? Do we leave the first one blank? There's problems with this. First normal form attempts to get rid of this first problem where we've got this book being stored in multiple different places. Now there's a couple of different ways a table can fail to be in first normal form. This is one of them, where we've got the ID, title, and author being stored in multiple places. First normal form means there must be no groups of repeated fields. So what we've got here is book ID, book title, book author, and due date. And then all four of those are repeated, and then all four of those are repeated. That's our repeated groups of attributes. That's what needs to not be there for first normal form. So what we would do is take that repeated data and just place it once in a separate table. We're not quite done yet, but this is what we've done. So the ID, title, author, and due date have been put in their own table, given a title like book, and everything else is left in loans. You can already tell this is starting to look more efficient. It's not perfect yet because we still need to know which books are included in this loan. So we want to be able to have 3 books for each loan. But each loan will also have to each book will also be able to be on multiple different loans because it'll be loaned out multiple times. So we need to make that somehow possible. So what generally ends up here is we try sticking a foreign key in one of the tables. This doesn't work. We've stuck the book ID in here, but the problem here, if the customer wants to borrow more than one book, they can't. We can put book ID 5 in there because book 5 has been loaned. What if they also are loaning book 6? Where do we put it? We could do book ID 1, book ID 2, book ID 3, and we're back to the repeated attributes. So that's not an option. Another way we could do it would be to put the loan ID in here. That solves this problem because now we can say book 6 is part of loan 1, book 8 is part of loan 1, and book 10 is part of loan 1 by taking those books and putting the loan ID 1 into each of them. But what happens when this book wants to be loaned to another customer later? We've already put loan ID, say 3 in there. What if it also wants to be loaned to loan ID 10? We can't do it. So this is a many-to-many relationship. Each book is loaned many times, and each loan contains many books, or 3 as the limit is there. So it's a many-to-many relationship, and you cannot do it with a single foreign key, primary key pair. You always end up with one thing not being able to be repeated. So to get round this, we use a compound primary key. This will eventually end up as a linked table in the middle, but to start off with, a compound primary key will do. A compound primary key is where we take 2 elements and say, combined, they are the primary key. In this case, we can put the loan ID in here, but make it and the book ID the compound primary key. This means now, so if in loan number 1, we want to do books 1, 2, and 3. So we put loan 1, book 1, and then we can also have the table, another table there we put loan 2 for book 1, and loan 3 for book 1, and loan 3 for book 2 as well. Because we're never doing the same combination of book and loan, we can keep repeating this table. It's still not very good because we're duplicating the author, due date, etc. every time we make a new book, but we have solved the problem of there being a many-to-many relationship between loans and book. And that's first normal form. Okay, before I go on to what second normal form is, and second normal form will sort out this problem of repeating this book information down here, I want to have a look at an exam question that deals with first normal form. This one presents first normal form in a different way. So it says, a chef keeps her recipes on a single table database system. It's a single table database, therefore it's not normalized, it's zero normal form. Figure 1 shows the recipe table. And this is what she stores. She stores the ID, the dish that she's making, so this is hummus, the recipe ingredients, including quantity, and this is where we have a bit of an issue. The preparation time, the cooking time, number of servings, and the cooking instructions. They're all fine. Now it turns out this chef has a supplier that she uses, and it has an online price list for ingredients, and that's what's given there. That the food item ID, food item name, pack size, and price. And that's where she gets her stuff from. Now the question says, which of the above two tables is not in first normal form? So remember, first normal form is no groups of repeated attributes. Now on our example, we had fields being repeated. We had book 1, book 2, book 3. In this we don't have that, but we still are having groups of repeated attributes. And we have it in here. Because in here what we've actually got is a weight and an ingredient. And then another weight, or a quantity, and an ingredient. Another quantity, an ingredient. And a quantity, an ingredient. So we've actually got quantity 1, ingredient 1, quantity 2, ingredient 2, quantity 3, ingredient 3, quantity 4, ingredient 4. They haven't stored it in separate fields, they've shoved it all into one, but it's still the same thing. It is still repeated attributes. So they've got quantity, ingredient, quantity, ingredient, quantity, ingredient. That's repetition, it's the same thing. So this one here is not first normal form for that reason. So the next question then says, why is it not in first normal form? Because the recipe ingredients contains groups of repeated attributes. The chef would like to be able to cost the ingredients for her dishes and is asking you to help her design a database which would allow the costing of dishes without retyping any of the price list details. Database theory states that database tables should be fully normalized. What does fully normalized mean, and why is it desirable that tables are fully normalized? We are getting on to doing the normalization, but first of all we have to explain it. If a table is fully normalized, that means that it is all the parts of normalization. We'll come back to that later on, but it's going to be no groups of repeated attributes, no partial key dependencies, no non-key dependencies. And why is it desirable? Well, this solves a lot of the problems that we get. We get minimized data repetition and we get no data redundancy. So let's go on to actually doing the normalization then. So when the data in figure 1 and figure 2 are stored in a fully normalized relational database, 3 relations, recipe, food item, and recipe ingredient, are needed. For each of these, complete the relation. So let's have a look at what we would have to actually do to normalize this. So put this over here. Put this over here, and let's have a look at how we could normalize this. There we go. So we know at the moment we've got a zero normal form table. We've got all our stuff shoved in here, but we know this is the part where we've got groups of repeated attributes. So our first normal form says we take out anything that's groups of repeated attributes. So what are the two things in there that are repeated? It's the quantity and the ingredient. So we'd probably have another table. I'll draw it out like this rather than do it in the relational style. This could be called, and we're told the names of it. Let's find out what, names need to be called. It says it will contain recipe, food item, and recipe ingredient. Now this is probably going to be recipe ingredient because it says there recipe ingredients. So recipe ingredient ingredient goes in there, and we put in the stuff that's in there. We'll probably need an ID as well, because all tables do need a primary key. So I'd say something like, let's call it ID for now, and then we'll have quantity and ingredient. Okay, then what gets left from this table will be everything other than this, but we will still need to form a relationship between them. If we think about it, this is going to be many to many, because each recipe will have many recipe ingredients, and each recipe ingredient will be used in many recipes. So we have to have that compound primary key thing going on. So we have the table left here, and this will be, let's make sure it's called what it's expecting it to be called, and it wants it to be called recipe, which is what this is. And that will have its recipe ID, the dish, and then there'll be the link to this, which we'll look at in a few seconds. And then there'll be the preparation time, the cooking time, number of servings, and cooking instructions. Okay, and we need to form a link to it. So I'm going to go with the compound primary key here for saying the ID for the recipe ingredient is part of the primary key, and the foreign key for here is part of that compound primary key. So just like the other example, we've ended up with a compound primary key there allowing a many-to-many relationship. So that's now first normal form. Now I'm going to take a pause there, we'll go back to theory on it, then we'll come back and have a look whether or not this is in second normal form, which it isn't. So I'll go back to the that's this. Okay. So that's first normal form, and this is very similar to what we've got. We've got the information about the loans or the recipe in that exam question, and our compound primary key here for the part that was being repeated. Then we look at second normal form, and this always applies to the table with the compound primary key. If you don't have a compound primary key, then you don't need to worry about second normal form. But we do have a compound primary key, and if you get a question out in the exam, it will have a compound primary key. So we look at this and we ask ourselves if any of the other fields in here that don't form part of the primary key, if any of these are dependent on just one of those. What I mean by dependent is, are any of these completely linked to just one? So if we look at this, for example, the due date here, if I look at all my records, if the book ID changes, then the due date is probably going to change, because if I've taken out a loan, one book might be due on one date, the other book might be due on another date. One might be for 1 week, one might be for 2 weeks. So it's entirely possible that changing the book rather, would change its due date. Similarly for loan ID, if a certain book is loaned as on one loan, it'll have a certain due date. On a different loan, it'll have a different due date. So changing the book ID can change the due date. Changing the loan ID can change the due date. The due date is dependent on both the book ID and the loan ID. Now the book title, that's not the case. If I take a particular book and I look at it on one loan, and it's called Bob Goes Fishing, and then I look at it on a different loan, it's still going to be called Bob Goes Fishing. A book's title doesn't change when it gets a different loan. Same for the author. Bob Goes Fishing, written by Bob, is not written by a different person when I loan it out a second time. So the book title and the book author are not at all dependent on the loan. Changing the loan is not going to change the title and author. The only thing that will change the title and author is changing the book ID. Because if you change the book ID, you've got a different book, which will have a different title and author. So in this case, the book title and book author are violating second normal form. They are dependent on part of a compound primary key and not the whole thing. So like last time, we take out the part that is dependent on part of that compound primary key. And we end up with this. We took out the book ID, the book title and the book author, and put those in their own table. So instead of this all being part of the compound primary key, it's now its own table. The book loan is left with the compound primary key and just the due date, because that was the only field that was dependent on both parts of the compound primary key. And then loans, which was left how it was. This is now second normal form because there are no partial key dependencies. It's not quite third normal form because in here there is a non-key dependency. That's one of the easier parts. But before we get to that, let's go back to the exam question. Okay, so let's have a look at this. In here, we've got a compound primary key consisting of ID and the recipe ingredient ID and the recipe ID. Are both of these dependent on both parts of it? So when we change this recipe ingredient in here to both the quantity change and the ingredient, well, actually, yes, they do. Because if in this one, for example, if I go to a completely different recipe ingredient, so instead of 250 grams of chickpeas, I'm looking at 6 cloves of garlic, both have changed. Similarly, if I go to a different recipe, so let's have a look at this recipe down here, it's all changed as well. So both changing the ingredient and changing the recipe both affect it. So this is already second normal form. In fact, if we look down here, yep, I do that every single time, and we have this one here, which is a food item, we can put that table in there. Which I think is the name of one of the tables it told us was going to be. Let's have a look. Food item, yeah, that's already there. Let's just put in what's there. So we've got our food ID, our food item name, our pack size, and our price. So this is already correct as part of that. Can we link these together? Well, we can. We can say that this ID up here can be a food item ID. So if we link that food item ID to here and this recipe ID to here, we actually have a normalized table, because this recipe ingredient will allow us to pick a recipe that the recipe ingredient belongs to and a food item from the supplier that it belongs to. So once we'd got that to first normal form, the rest of it actually fell into place. To make certain of that, I'm just going to check third normal form. We'll have a look what third normal form is and we'll make sure that nothing in here needs normalizing further. But the fact that it tells us only 3 tables tells us it probably won't. So let's go back to this and we'll look at third normal form. In this case, we look for if there are any non-key dependencies. A non-key dependency is anything in any of these tables that depends on something which isn't already a primary key. Now in these two, the book title is dependent on the book ID, as is the author. If you change the book ID, both of those will change. Fine. In this one, the due date is dependent on both of those parts. We've already established that when we did second normal form. In this one, let's go through them all. The date, is that dependent on the loan ID? If I change the loan ID to a different loan, is the date going to change? Probably yes. Is the payment type likely to change? Yes, because different loans will have different payment types. Is the customer ID going to change? Yes, because different customers will be on there. Is the first name going to change? Well, yes, it probably will, but only because the customer ID has changed. If I change the customer ID, if the customer ID stays the same, then first name, surname, and address will stay the same, regardless of the loan. So if I change the loan to loan 5, but keep customer ID at 2, then all of these will stay the same. In other words, loan ID doesn't directly affect first name, surname, or address. Only the customer ID does. This is a non-key dependency. First name, surname, and address are all dependent on the customer ID, which is not a primary key. So that's not third normal form. So like everything else when we discover there's a violation of normalized normal forms, we take it out of the table. So customers gets its own table with its customer ID as a primary key, and first name, surname and address, all the things that were dependent on customer ID are taken out. The customer ID field is just left in there because this is actually a one-to-many relationship, because each loan will only be for one customer, but each customer can have many loans, so it's one-to-many. And this is now fully normalized because there are no groups of repeated data. They were taken out over here. There's no partial key dependencies. They were taken out over here. And there's no non-key dependencies. They were taken out over here. So let's have a look back at that exam question. Is this fully normalized? So this recipe ID here, by the way, is the primary key. So is the name of the recipe, the name of the dish, dependent on the recipe ID? Yeah, it is. Is the preparation time? Yeah, it is. Get a different recipe, it'll have different preparation time. Cooking time, same thing. Number of servings, yeah, depends on the recipe. Some recipes might make 5 servings, some might have 3. And cooking instructions, yeah, different cooking instructions for each recipe. So that's no non-key dependencies there. We know there aren't in there because we've already looked at those for second normal form. So that is fully normalized. It turns out for this particular question, the only thing that was needed was putting it into first normal form. It even told us that in the question by saying which of the above two tables is not in first normal form. And it's worth knowing this is the only question in the whole of the history of AQA questions that are publicly available where you're actually asked to perform a full normalization, and it's only a first normal form. Every other question has either shown you a normalization and asked which normalization step had taken place, or has just asked about why something is or isn't normalized, or why it should be, or what normalization means, or something like that. This is the only question I've found where it gives you a table, says this is not normalized, and then says normalize it. So this is as tough as it gets. This only required one step of normalization, and it told you that it was first normal form that was missing. So as long as you would be able to do something like this, this is as hard a question as you're going to get. More realistically, the type of question you're going to get, we want like this. This is one of the standard SQL database questions. You get some stuff on SQL, you get some stuff on normalization, but the kind of stuff it tends to ask about normalization is this. It says, these questions are in third normal form. What does this mean, and why is it important that the relations are in a relational database in third normal form? Well, notice that seems quite familiar. If we scroll up here, it said, what does fully normalized mean? Why is it desirable? What's the meaning? Why is it important? Those two questions show up a lot, and getting those right is important. And we need to put exactly the right definitions for it. I said it earlier, so I'll just go through it again. Let's just bring this back up. For something to be normalized, the 3 stages of normalization must be met. So in first normal form, the tables must have no groups of repeated fields. That's the first normal form. For second normal form, there must be no partial key dependencies, and for third normal form, there must be no non-key dependencies. So that's the correct answer to that one. There's 2 marks. Usually the 3 of those have to be given to get both of them. That's what fully normalized means. It means there are no groups of repeated fields, there are no partial key dependencies, and there are no non-key dependencies. Why is it desirable to have tables that are fully normalized? Well, there's just 2 definitions for that you've just got to remember. The first one is it means there is minimal data repetition. And importantly there is the word minimal. You will not get the mark if you say there is no data repetition, because the foreign keys are repeated. If, say, in our library one, the same book is loaned out multiple times, then that book's ID will appear multiple times in the loan table. There's different in different records. So there is some repetition, but that repetition is minimized to only be a foreign key, a single ID, rather than all the groups of attributes, which is what we don't want, which is what happens when we do first normal form. Okay, so minimal data repetition. Some repetition happens, but it's minimal. Don't say no data repetition. However, you can say there is no data redundancy. We are not storing the same thing multiple times for no reason. So if, for example, we stored, like in this, the recipe one and the initial one, we put the amount and ingredient, and then the amount and ingredient, amount and ingredient, amount and ingredient, or on the book one where we put book 1, book 2, book 3, or more, a better example is where you put the customer ID in and you put their first name, last name and address, and then they loan out another book, so you put their ID in and their first name, last name and address, and another book and put first name, last name, address. We've stored that customer's first name, last name and address every time he takes a book out. That's redundancy, because we only need it once. Once we know where he lives, we know that's dependent on the ID, we should just be able to take the ID and look up the rest. So redundancy is unnecessarily storing the same information multiple times, and there should be none of that. Although we're repeating the primary key, the foreign key, that's a necessity because it indicates there's been another loan. The data redundancy is when we unnecessarily repeat it. So the correct answers to why is it desirable to have tables that are fully normalized, there is minimized data repetition and no data redundancy. Okay, right, so just to wrap this up, so this is what it says you have to do in the specification. Normalize relations to third normal form. Students should know what properties are possessed by a relation in third normal form. In other words, that they are no groups of repeated attributes, no partial key dependencies, no non-key dependencies, and understand why databases are normalized, because it minimizes data repetition and eliminates data redundancy. That's the stuff it says there. It will always find a way to ask that in one way or another. That's all the normalization is about. If we're not sure about it, or if you need to look at that one again, in normalization, I've stepped through there explaining it. I've put what the advantages are, minimizes data duplication or repetition, eliminates data redundancies. Also, the mark scheme appears regularly, prevents data update anomalies. In other words, if you have to update someone's address, you don't accidentally update their address in one record and leave it what it was in another record, which can happen if we've got data redundancy. So that's sometimes accepted as well. So you've got your definition of first normal form, no repeated groups of attributes, definition of second normal form, no partial key dependencies, definition of third normal form, no non-key dependencies, and the advantages. Ultimately, that's the stuff you need to know for this. Okay, so that question, the recipe one, is on the VLE. If you want to have a go at it independently and see if you can figure it out, come back and look at this later if you want to try it again. But that's worth going at. So I'll put another video up in a little bit for SQL, which is the other hard part of this, but that's normalization. It's one of the ones that was highlighted as being difficult. Have a go at that question. Okay, thank you.